Welcome to Vega Kids. Learn with fun.
Welcome to Classroom. Topic: Understanding Maps, Globes and Time Zones. A comprehensive guide. A map and its components. What is a map? A map is essentially a drawing or representation of an area. It could be as small as a village or as large as the entire world. When you look at a map, you're viewing the surface from a top-down perspective. Types of maps: physical maps, political maps, thematic maps. Physical maps. These maps highlight natural features such as mountains, rivers, and oceans. They help us visualize the physical landscape of an area. Political maps. These focus on political boundaries and locations. They show details like countries, states, cities, and their boundaries. For instance, a map of India displays its states, union territories, and capitals. Thematic maps. These maps present specific types of information, such as population density, climate, or economic activities. They are used to focus on particular themes or data. Key components of maps: scale direction symbols. Scale. The scale of a map tells us how distances on the map relate to actual distances on the ground. For example, on a city map, 1 centimetre might represent 500 metres in real life. On a larger map, like one of a country, the scale might show 1 centimetre as 500 kilometres. The scale is crucial for understanding how far apart places are on a map. Direction. Maps use directions to help us navigate. The cardinal directions are north, east, south, and west. Intermediate directions like northeast, NE, and southwest, SW, provide more precision. Most maps have an arrow marked N pointing to the north. Symbols. Since it's impractical to draw every detail on a map, symbols are used to represent different features. For example, symbols might indicate schools, hospitals, rivers, or roads. Each map uses a specific set of symbols to keep the map clear and easy to read. Different countries or regions may use different symbols, but they all serve the same purpose of simplifying complex information: mapping the Earth. Why mapping the Earth is challenging. Our planet is nearly spherical, not flat. Representing a sphere accurately on a flat piece of paper is tricky. Imagine peeling an orange in large sections and trying to flatten them on a table. You'll notice it's almost impossible without tearing or distorting the peel. This is why we use globes to represent Earth's geography. A globe, being a sphere, accurately reflects the Earth's shape and features, unlike flat maps. Features of a globe. A globe represents the Earth's geography more accurately than a flat map. It shows the Earth's surface as a whole, preserving its spherical shape. Understanding coordinates. Coordinates help us pinpoint locations accurately, much like a chessboard or a market grid. Latitude, longitude. Latitude. Think of latitude as the distance from the equator, which divides the Earth into northern and southern hemispheres. Lines of latitude run parallel to the equator and are called parallels. The equator is at 0 degree latitude, while the poles are at 90 degrees north and south. Latitude affects climate, with tropical regions near the equator being hot and polar regions being cold. Longitude. Longitude lines, or meridians, run from the North Pole to the South Pole. They help us measure distances east or west of the prime meridian, which is at 0 degree longitude and passes through Greenwich, England. Longitude ranges from 0 degrees to 180 degrees east or west. For example, New York is around 74 degrees longitude, Delhi is 77 degrees, and Tokyo is 140 degrees. Longitude helps us determine time zones as Earth rotates and different places experience day and night at different times. By using both latitude and longitude, we can pinpoint any location on Earth. For instance, Delhi's coordinates are approximately 29 degrees latitude and 77 degrees longitude. This coordinate system forms a grid on the globe, making it easier to locate places precisely. Maps and globes are incredible tools that help us understand our world. By learning about coordinates, we can better navigate and explore the Earth's diverse landscapes. Understanding time zones. How time zones work. Imagine the Earth spinning on its axis from west to east, completing one full rotation every 24 hours. This rotation is equivalent to 360 degrees, so each hour the Earth rotates 15 degrees, 360 degrees divided by 24 hours. To keep track of time, we mark the meridians of longitude every 15 degrees. Starting from the prime meridian, 0 degree, moving eastward, you'll find time increases by 1 hour for every 15-degree meridian. So if it's 12 p.m. noon at Greenwich, 0 degree, it will be 1 p.m. at 15 degree, 2 p.m. at 30 degree, and so on. Conversely, moving westward, the time decreases. It would be 11 a.m. at 15 degree line, 10 a.m. at 30 degree lines, etc. Standard time and time zones. Since using local time for every location would be impractical, most countries use a standard time based on a specific meridian passing through them. For example, Indian Standard Time, IST, is 5 hours and 30 minutes ahead of Greenwich Mean Time, GMT. The world is divided into time zones that roughly follow these 15-degree meridian divisions. However, time zone boundaries are not always straight lines. They often adjust to fit national borders and local needs. On a world map, you'll see time zones marked with hours added to or subtracted from GMT. The International Date Line. The International Date Line, IDL, is located at approximately 180-degree longitude, opposite the prime meridian. Crossing this line requires a date adjustment on your watch. Time zones help us coordinate activities across different regions, ensuring that everyone stays on the same page, no matter where they are in the world.
Thanks for watching. Don't forget to like, subscribe, and hit that bell for more fun educational adventures. Bye-bye.
Thanks for watching.